very good evening. We are from Group D, and today we're gonna present to you guys about the group assignment. So right now we have Nur Zafira, and second we have Nur Kwamarina. We also have Nur Najwa Jika Afrina. So okay, we start with part one. Part one. So the question is obtain a joint probability density function PDF of two random variables x and y and complete the following items. So first, find the marginal PDF for x and y and show that both marginal density functions satisfies the properties of being a PDF. So right now we have to find the joint probability density function, which is we can write as fxy in bracket xy equal to e the power of negative or equal to 0, and also y or equal to 0, and 0 is for otherwise. So and then after you find the probability density function, you can also straight find the marginal PDF. First, you have to find the marginal PDF of x. So for the formula, we know we have fx in bracket x equal to 0 to infinity fxy xy in bracket xy dy, and then you have to integrate first. So we put there as e power of negative x minus y dy. So if we integrate, we know that integrate e negative y dy equal to 1, or either you integrate e power of negative x dx will also equal to 1. Bracket x equal to e power of negative x for x equal or more than 0. So after that, we have to find the marginal PDF of y. So we use the same formula as the PDF of x, fy, but in terms of y. So we use fy in bracket y equal to 0 to infinity fxy equal to fxy in bracket xy dx. So the difference is in the marginal PDF of x, you use dy, but in marginal PDF of y, we use dx. So there's two different things there. So we integrate e power of negative x to y, a minus y dx. We got e, and then thus fy in bracket y equal to e power of negative y for y equal or more than 0, and 0 is otherwise. So the question number 2, Roman 2, calculate correlation of PXY. So we know the formula for correlation is PXY equal to covariance XY over sigma X sigma Y. Um, over CX, what CX. So if there is any things that wrong, you guys can correct me. So if there is, okay. So We given the equation for probability density function is fxy in bracket xy equal to e power f negative x negative y for x equal or more. So first we need to calculate the mean. So bawah Zurin. So first you need to calculate the mean. So mu x so equal to 0 to infinity f fx. So you substitute into the fx. So you got x e power of negative x dx. Then you integrate as a normal thing. 1. Mu x 1. So same goes to the mu y. So same goes to the mu y. Mu y also you use the same formula, but you change it into the variable of y. So you got y fy in bracket y dy. So you also will get 1. And then you calculate the variance. For formula of variance is equal to e in bracket x power of 2 minus ex square. So just substitute the ex square. E in bracket x square is equal to 0 to infinity x square e power of negative x dx. So that one, if you integrate, you will get 2. Therefore, for the variance, 2 minus 1 power of 2 is equal to 1, and then you have to square root the 1, and also you still got 1. Same goes to the variance for variable y. You will get 1 also. And then after that, you put all the mean and also variance into correlation formula, which is covariance. Covariance. In bracket xy equal to exy minus ex and also ey. So that you will have double integration, 0 to infinity, integrate 0 to infinity xy, and also e power of negative x negative y dy dx. So you will get e in bracket xy is 1. So the covariance xy is equal to 1 minus 1 times 1, which means the answer is 0. And then you put in the pxy is equal to covariance in bracket xy over sigma x, variance x and also variance y, which is 0 over 1 times 1 equals to 0. And then for the last question is variance xy equal to y. So we know the equation is the function is fxy in bracket xy is equal to e power of negative x negative y. So for fxy bracket xy is equal to fxy dapat sangat muka in bracket xy over fy bracket y. So you put you sub the equation into the formula. So you got e power of negative x minus y over e power of negative y. And then you minus, you potong-potong, and then you get the answer e power of negative x. So you know the variance, the formula of variance is equal to e x in bracket x square y minus exy power of 2. The answer will get 1. So you first you find the exy, you integrate 0 to infinity x e power of negative x dx. You got 1. So for the next one, e power in bracket x square y equal to y equal to 0 to infinity. Then you put x square times e power of negative x dx. You got 2. So the variance is 2 minus in bracket 2 minus 1 power of 2. So you get 1. So that's all for my part. So we go to the next part, part 2.
For part 2, I am Nona Najwa binti Muhammad Nazan. I am going to explain for part 2. Okay, first, I choose discrete function, which is y equals to 4x minus 2. And then, next, we have to construct a table which contain value of x from 1 until 6. And then, substitute the value of x into function of y, and then we get the value of fx, which is 2, 6, 10, 14, 18, and 22. Next, we have to find moment generating function using a formula of mx in bracket t. The formula is summation of x e power of tx times fx. So we will get the t, we have to substitute 2 in bracket et until 66 e power of 60. Next, we have to let t equal to 0, and then we substitute 0 into t. We will get 2 in bracket 1 plus 6 plus 15 plus 28 plus 44 plus 66 equals to 322. Next, we have to find variance. How to find variance? Variance, we have to find e expected value but x power of 2, where we have to differentiate twice for the equation before, and then we have to let t equal to 0 also, same like before. So we will get 1582. For variance, the formula is e x square minus expected value square. So 1582 minus 322 is equals to 1260. Okay, that's all for part 2. Thank you very much.
For part 3, read a video obtain a moment generating function for two random variables from any distribution. So for the discrete, table fx from x 1 to 3 for y 1 2 3. So a joint generating function x and y. If we add all and we get 1. B, find mean and variance for x and y. New x equal to ex equal to sum x, p x equal to x. 1, so 1 times 0.25 plus 2 times 0.5 plus 3 times 0.25. So the answer is 2. For mu y, ey equal to sum y, py equal to y. 1 times 0.41 plus 2 times 0.35 plus 3 times 0.25, and we get 1.85. For ex square, the formula is sum x square px equal to x. So we have to kuasa duakan dia. one one square times 0.25 plus 2 square times 0.5 plus 3 square times 0.25, and the answer is 4.5. Same goes to EXY. We have 4.05. For variance X, the equation is x EX square minus EX square. So the answer here we get 0.5. Same goes to variant Y. We get 0.6275. C. We need to find covariance XY. The equation of covariance XY is EXY minus EXEY. So here we already have EX and EY. So we need to find EXY. EXY. So this is the formula of EXY. Sum XY PX equal to X, PY equal to Y. So we get 3.7. So we substitute into this formula and we get 0 for the covariance.
Then we find the moment generating function. We are going to use the formula summation of fxy times with e power of x t1 plus y t2. And then we are going to substitute the data from the data given above into the formula, and then we will get the function. And then to find the covariance by using the function, firstly find for mx t, and then we substitute for t2 equals to 0, and then we will get the function, and then we differentiate to the power of t, and then we substitute t equals to 0, and we will get for mxt equals to 2.
Continuous, we are going to take a look at this example question, which is fxy equals to e power of negative 2x minus 2y, which x is 0 until infinity and y is 0 until infinity, and the other one is 0 otherwise. The moment generating function mxy_st for two random variables in a continuous distribution can be obtained by using this formula mxy_st, which st is a constant. Integrate 0 until double integration 0 until infinity exponent sx plus ty fxy dx dy, and then we substitute the value of fx into the equation, and then we simplify the exponent, substitute the value, and we evaluate the integral, and by integrating each integral separately, and then we get the value for for the x is 1 over 2 minus s for s less than 2, and 1 over 2 minus t for t less than 2. From solution above, we get that mxy_st is equals to 1 over 2 minus s, 2 minus t for s less than 2 and t less than 2. So to find the covariance value, we use covariance xy equals to exy minus exey. From the moment generating function mxy_st, we can find ex, ey, and exy using partial derivative with respect to s and t. And then for ex, we substitute the value we get just now, and we will get the value for ex is 1 over 4. Zurin bawah sikit.
And then for EY, we substitute the value from what we get above also, and then we get 1 over 4. For EXY, we get 1 over 16, and we substitute all the value we get into the formula covariant, which is EXY minus EX times EY. Bawah Zulin. And then we get the answer is 0. Therefore, the covariance for XY for the given continuous distribution is 0. Okay, that's all from us. Thank you.